Hi, I'm Yiru Chen. I'm demonstrating TSExplain, a tool to help users understand the underlying evolving explanations for any aggregated time series. This is a joint work with Sulu Huang at Microsoft. If people want to see what's happening, they can drag to generate a visualization and see the changes. Now, monitoring KPI is very easy in current BI tools. Diagnosing KPI change can tell people why it is happening. This is equally crucial, but it's not easy in BI tool. Users will need to manually drill down to each single or combined dimensions. Instead of manually drill down to each single or combined dimensions, can we augment time series explanation? If so, such a tool could help users surface underlying data, expedite data analysis, and recommend where to look at. There are many academic work focusing on data explanation. Diff operator is a general operator which integrates data X-ray, TSExplain, and scoping. Their data explanation procedure is to find the explanations to distinguish between two datasets, R dataset, the test set, and S the control set. The explanation definition is data segment that are represented by the conjunction of at most k predicates. They propose some metric to find the explanation that maximize the metric. This is one example risk ratio, which means to find the explanation that appears much more times in R dataset than the S dataset. Cascading analysis is similar, but the only difference is that it needs to find at most k non-overlapping predicates. There are also some data explanation features in industry tools. The left figure shows key influencer in Power BI, and on the right side, it is the explain data feature in Tableau. For instance, in Tableau, it wants to explain why the sum of trip distance 8,800 in August is higher than expected, and it found that the higher value is partially explained by the distribution of values for weather conditions. Till now, the data explanation tools we have looked at in the related work are all about two sets. Instead of explaining two-set difference, what our work wants to focus on is to explain the trend line. Trend line consists of a series of timestamps as x-axis and aggregated value as y-axis. Here is one example of trend line. From the observation, we can see that different periods have different trends, up, down, flat. The trend line has multiple different reasons at varying time periods. For example, the first flat period is because of explanation 1, and the second uptrend is because of explanation 2. What we want to do is to show the users the underlying evolving explanations. We abstract this problem as a segmentation problem. Before I started our problem formulation, I want to disclaim that explanation is not equal to causality because we do not require domain knowledge for causal analysis. In our case, as our explanation is the subdata contributes to the overall trend, we use predicates to represent such subdata. What we are doing here is to surfacing some underlying pattern or trend. Next, we will describe in detail the problem formulation, input, output, optimization goal. Our TSExplain takes trend line and explain feature as input. Trend line is consisted of ordered time domain as x-axis and aggregated measures as y-axis. Users will leverage their domain knowledge to give explain features, for example, vendor, category, state, county. State county here specifies the hierarchical data. Our output is a segmentation scheme, which segments the timeline into multiple segments with coherent explanations in each segment. For each segment, we demonstrate at most the top k explanations. Explanations are non-overlapping data segments represented by predicates like state equals to Washington, county equals to King, or state equals to New York. Here comes the question, what is a good segment? We have two considerations. The first one is it should be concise. There should not be too many segments, otherwise it will exceed users' perception limitation. The second consideration is pureness, which means each segment should have as pure explanations as possible. For the left chart, the overall explanation is Florida, Texas, Arizona, and the left small segment explanation is New York, New Jersey, Massachusetts, and the right small segment explanation is Florida, Texas, and Arizona. This larger segment is not totally consistent with the small subsegment. In contrast, this right one, the overall and the two small segments explanation are all New York, New Jersey, and Massachusetts. This large one is very consistent with the small ones. Thus, we would prefer the right one, and we think the right one segmentation has pure explanations. Here we demonstrate how to use TSExplain to find the underlying evolving explanations for the daily confirmed COVID-19 cases. First, we choose the COVID-19 dataset and date as x-axis, daily confirmed cases as y-axis. As we can see, the time series is very fuzzy, and we can choose to smooth the data using, let's say, 7-day average. After looking at the trend, users may wonder why the daily confirmed number is going ups and downs. They tried to drill down to state level by adding state as the legend and brush over the overview chart to zoom in details. However, it is overwhelming to look at this chart with all the states, and it's hard to interpret what are the top states that contribute most to the overall trend change. TSExplain to the rescue. For instance, if the user is interested in explaining the trend during the period of July 22nd to December 31st, we can set the time range accordingly. Next, the user can specify state as the explain by feature based on their domain knowledge. Users can then leave other configurations as default. For instance, the metric used is absolute change. At a high level, absolute change measures the absolute value each state contributes to the overall trend rise or fall. And we focus on the top 3 explanations with the largest absolute change. TSExplain will then automatically segment the whole time series into multiple segments, and each segment has its own inherent and cohesive explanations. Here, TSExplain segments the time series into 7 segments. The table shows the top 3 explanations during each period. Pureness evaluates how consistent these explanations are in the corresponding segments. Plus and minus denote the rise or fall, respectively. The bottom chart visualizes the trends of each segment. Users can interpret the evolving explanations over time by looking at the top explanations during different periods. Specifically, from 2020 March 7th to 2020 April 6th, New York, New Jersey, and Massachusetts rise contributed to the overall rise in the U.S., while from 2020 April 6 to 2020 June 2nd, even New York, New Jersey declined dramatically. TSExplain captures an interesting pattern that California starts to rise. During holiday season 2020, the last segment, California and New York surges again while Illinois declines. As users may have noticed, some segment score is relatively low. For example, we can find from July 18th to September 29th, the pureness score is just around 0.55, and the top 3 explanations TSExplain returns are the falls of Florida, California, and Texas. This indicates that besides these explanations, there are more influencers underlying the fall trend. We can zoom into the period from July 18th to September 29th. From the visualization, we can roughly see that Texas does not simply fall, instead, it falls and rises from September 13th. Let's run TSExplain to reveal more detailed explanations.
Instead of letting TSExplain select the number of segments, we can also manually explore with different number of segments and choose the most appropriate one. This is similar to varying k in k-means clustering. Here, let's select 3 as an example. Here shows the results. Before September 8th, the explanations are Florida, Texas, and California. Next, the main reason is the rise of Texas and the fall of Texas. From the pureness score, we can see the first and the last segments both get pure explanations. However, from September 8th to September 26th, the pureness score is relatively low. Next step, we dig into the period from September 8th to September 26th. This time, we still set the segment number as 3 for this short period, and we run TSExplain. We can see from September 16th to September 22nd, Texas confirmed cases is actually decreasing a little bit, which it doesn't catch before.
Okay, till now, we demonstrated the evolving explanation of daily confirmed cases and drill into the details of the explanation from July to September. Next, let's try to explain the total confirmed cases. We simply change the y-axis from daily confirmed cases to total confirmed cases, and we still apply a 7-day moving average. Here we can see the overall trend is rising up when we set the legend as state and show each state total confirmed cases trend. We can see each state rises at a different speed during different time periods. There are so much information in the visualization that it is hard for users to identify the main explanations at the different periods. Now we run TSExplain to help users find the evolving explanations from January 22nd to December 31st, and the explain by feature is state. TSExplain quickly shows us the results. The whole time series is segmented into 4 small segments, and each segment is of high pureness score. The early stage is California, and next Washington State rises. Later on, New York breaks out. From May 21st to December 31st, California, Texas, Florida increase sharply.
Note that when y-axis is total confirmed cases, the top explanations in each segment are states that have a large number of newly confirmed cases, which is very different from the explanations when y is daily confirmed cases.
This does match the news report that in early stage, the COVID cases are mainly in the West Coast. And from March to June, New York City was an early epicenter of the COVID-19 pandemic in the United States. Afterwards, California surpasses New York as the state with most coronavirus cases. Besides COVID-19 dataset, we can also try other datasets. For example, we can try SP500 dataset to inspect what factors would influence SP500 index to rise and fall. Here, we configure the y-axis as the free float cap, which is the SP500 index value. As we can see from the visualization, there is a dip in the March of 2020. This is the 2020 stock market crash when SP500 drops and triggers market-wide circuit breakers. Many people may wonder why. What are the reasons behind this drop and rise? Let's inspect the underlying influencers of SP500 index fall and rise.
Here, we have time series from January 2nd to October 1st. In the visualization, we can select different legends to see each categories or each subcategories or each symbol's trend. To run TSExplain, besides selecting one attribute each time, we can also select multiple features as our explain by features. Here, let's select all three attributes as our explain by features. Note that category, subcategory, and symbol are hierarchical features, which means one category consists of many subcategories, and one subcategory consists of many symbols. What would be the evolving explanation for SP500 dataset? TSExplain shows us 4 periods and their explanations. Before February 10th, the SP500 index slightly rises due to the rises of technology, consumer cyclical, while energy category slightly drops. From Feb 10th to March 25th, that's the stock market crash. And the main reasons are the falls of technology, financial, and communication service. Later on, the rise and fall are both due to technology. We can see that despite we have chosen 3 features, but the explanations are all predicates of attribute category. This is because subcategory and symbols absolute change are too small compared to categories change. We can also discover an interesting fact that financial drops dramatically, but it does not bounce back a lot like technology and communication service does during the stock market recovery. The bottom figure compares the overall trend with the trend with top influencers only in each subsegment. The trends with top influencers only are already in the similar shape with the overall ones, which also indicates these top influencers can explain the up and downs very well. If we would like to understand which stocks could explain the trend, we can select the explain by features as stock symbol. As we can see, Microsoft, Apple, Amazon, and Google are the main reasons for the rise and fall. This also further explains the early result that the main factor is the technology category. Also, we can find Amazon is not declining just much like Apple, Microsoft, Google during the stock market crash, maybe due to its advantage on online shopping.
To summarize, TSExplain is a tool that can help users understand the underlying evolving explanations for any aggregated time series interactively. That's all my presentation. Thank you for watching.